Hey everyone, so just a quick review from Algebra 1. These are some of the operations with radicals that you're going to need to be successful in geometry. So starting out, we must know our perfect squares. So we know 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 squared, 36, 7 squared, 49, 8 squared, 64, 9 squared, 81, and 10 squared is 100. So those numbers in green are your perfect squares from 1 to 10. All right, so you need to memorize these, know these by heart, recognize these numbers in any problem. So the first one, we're just going to start out simplifying some easy radicals. So start with the number underneath the radical, so I have 12. You need to find the largest perfect square number that goes evenly into 12. So in this case, we know that 4 goes into 12 3 times. So my largest perfect square number that goes into 12 is 4. So I'm going to write that one first when I draw my little tree. So then now I can take the square root of 4, which is 2. And since there is no perfect number square root of 3, I'm going to bring that down. And then that's my answer. That is simplified. All right, simplify the square root of 18. So again, we're going to look at our biggest perfect square number that goes evenly into 18. So 16 obviously doesn't go evenly. It goes in once, but then there's a remainder of 2. 9 goes into 18 twice. So again, write the perfect square number first, and it goes into 18 twice. Square root of 9 is 3, and bring down the square root of 2. And then that one's the answer. All right, now we have a variable. So similar to example number 1, we have 12 underneath the radical. So we can start again by using square root of 4 times the square root of 3. So that'll simplify our number. And square root of 4 is 2. Bring down the square root of 3. Notice I saved some room for the x. Now when you take the square root of x to the 4th power, you're taking out pairs of x. So if I have 4 x's, how many pairs can I make? I can make 2 pairs, so that becomes the exponent on the x outside of the radical. All right, so simplifying 180x cubed. Now, you can do this the long way. So remember, our perfect squares are 1, 4, 9, 16, 25, 36, 49, and so on. If you like working with smaller numbers, that's great. You can do that. So 180, I'm going to pick 4 as my perfect square. So 180 divided by 4 gives me 45. So that goes in evenly. Now I'm going to take out this 2. So square root of 4 is 2, leaving me with square root 45. Now I can simplify that even further. 4 does not go in evenly, so I'm going to move up to 9. 9 goes into 45 5 times. So now the square root of 9 is going to give me 3. Don't forget to bring down that 2. 2 times 3 is 6. Now I'm going to leave some room for my variable. Up here it says I have 3 x's. So how many pairs can I make out of those 3? Only 1. So it's going to be an exponent of 1. And then I have 1 remaining. So 1 has to go back underneath the radical. All right, now multiplying, we can only multiply what's underneath the radical. So square root of 3 times square root of 3 is equal to the square root of 9. And then to simplify that, square root of 9 is 3. Again, multiply what's on the inside with each other and then what's on the outside with each other. So we're going to pretend that this is a 1. So 7 times 1 is 7. And square root of 5 times square root of 5. 5 times 5 is 25. Now take the square root of 25, and we know that is 5. So that comes on the outside. And then 7 times 5 is 35. All right, we're going to multiply then simplify. So again, multiply what's on the outside. 4 times 6 is 24. Then multiply what's on the inside. 3 times 6 is 18. So we saw from example 2 that 18 reduces to square root 9 times the square root of 2, which gives me 3 times the square root of 2, bring down that 24. And then 24 times 3 is 72, and bring down the square root of 2. All right, and then dividing. So there's 2 ways you can do this. I'm going to show you the hard way first and then the easy way the second way. So anytime you divide by a radical, you're going to multiply by 1, and it has to be in that radical form. So remember, anything divided by itself gives you 1. So multiply across the top. You can't combine those, so 30 square root 3. On the bottom, square root of 3 times square root of 3, which we saw from example 5, gives us square root of 9. Square root of 9 is 3. And then we can combine whatever's on the outside. So 30 divided by 3 gives you 10. And then I can't touch that radical, so bring that down. So there is the mathematical worked out way to do that problem. Now the easy way you can just say 30 divided by 3, so the number inside the radical is 10. And then you just bring that guy over. Same answer. Okay, so you take the number on top of your fraction, divide by the number under the radical to get the number outside, and then you bring that entire radical over to your answer. So now here, dividing 10 square root 2 divided by the square root of 2, anytime you divide something by itself, it cancels out and gives you 1. 10 times 1 is